And okay, I'm recording. And I think I should be sharing my desktop here. Can you guys see Rhino? Hopefully. All right. So.
Whoa, Josh, are you recording?
Oh, I am recording. Yes, thank you. Yes, I am. I'm screen sharing and recording. Good eye. Yep. Way to keep me on top. Way to keep me on my toes. There we go. I'm already on top of things. I don't know. Not sure why my window isn't resizing here. Interesting. Now, Windows has been acting up. I suspect that part of it is that it thinks that I'm pirating Windows at the moment because I haven't been on campus to activate the license server on all these license server thingy network. I don't know. There it goes, starting to catch up. But it seems to be really laggy in Windows here. It's really bizarre. And I keep changing it, so maybe that's part of my problem. But what we're going to do is, you guys have been doing those form studies, looking at creating these interesting surface classifications based off of math. A number of them are picked based off of their sort of reference to this sort of notion of inside out, right? This sort of self-intersections, strange inflections, sort of ambiguity between what's inside and outside. Is, I think, something that we're looking at as a as some of these lost geometries that we typically just sort of discard when they happen, and maybe thinking about them as a new architectural vocabulary by which we deal with the whole range of issues involved with architecture, let's say this coming century. So and so you have a series of inside out assemblies, I would argue, the start of which anyway, that you guys have generated. And so the next step, I think, is to start to zero in on certain portions of those, right? Something I've called sort of inside out moment, right? So you're going to start to look at these assemblies and start to identify some of these moments of inflection or self-intersection, or where interior suddenly becomes exterior without really passing through a formal threshold. You're going to start to identify those moments, and then we're going to start to crop to those, right? And then begin to examine those in section, right? And so you'll be creating these sort of sectional models of portions of the geometries that you created, right? That's just the sort of quick way of saying what I was trying to elaborate. And so you're not going to just take one large form and just start slicing and dicing it yet. We're going to identify portions. We're going to use an 8-inch by 8-inch cube to sort of, as our frame, to sort of sample portions of these inside out assemblies that you've created. And then we'll look at those as opportunities to create models of. Okay, so further elaborate. We did a series of these last year, and in 42 Studio, I meant to have these examples up for you, and I apologize, I didn't think about it at the time.
I'm holding mine up right now. If you guys.
Yeah. I'll have a couple of photos, including that one, in a minute here too. Maybe. Here we go. Okay. And so these models were taking a sampling cross-section of a piece of architecture, and then rather than in plan, but in section, slicing it almost like topo pancake model. So this was Boolean Studio last year. So these are looking at architecture in section. These are sectional models. And so you can begin to see that the more sort of inflections and oblique geometry and curved geometry you have, the more interesting these actually become. Right? As you first sample a portion of them and then slice and dice them with vertical planes, right? And so that's the sort of format that we're going to take. Right? You can start to see here. In this case, this was laser cut museum board. And what's interesting is that usually I think is a bug of the laser cutter, sort of having the dark scorched edges where things were actually cut. In this case, it actually became a feature to sort of help differentiate the different layerings. So it almost was like a sort of line weight added to the edges, which is kind of a really nice touch. You can start to see, there was Gabby's actually, right? Sort of these sections, how both planar and non-planar geometries began to emerge and then begin to be able to be read. Some with more poche and some with less, right? And so this is one way to sort of get beyond just a sort of interesting form or object and starting to look at what's happening inside. Okay, and I think that's really important to do. We want to start to understand what's happening not only formally, but spatially on the inside, right? Okay, so yeah, that was Gabby's actually, right? So even something that's just slightly curved, right, suddenly becomes accentuated in these sort of contour models turned sideways, right, as section. There's Doug. I don't know why he's in there. Yeah. All right, cool. So anywho, so I thought maybe we'd go through this process. Okay. What I'm going to have you do, and I just have up here an example of, let's say, some inside out assemblies, right? I was using gyroids. I think I've used these before when we've talked about some of the sub-D stuff, right? And I've started putting them together into interesting sort of assemblies, spatial assemblies, I would say, that are inside out. More than one, actually, that I can look at and begin to sort of zoom in on, begin to cut and et cetera, right? So first things first, our sampling size, right? Each of these are going to be 8 inches by 8 inches by 8 inch sort of models, right? So probably one of the first things I'm going to do is go ahead and draw that up. Maybe in my case, everybody has their own way of doing these things. I'm just going to draw a polyline, start at 0, 0, 0, and then make 8 inch edges here. I'll zoom in on what I'm doing here in perspective view a little better. Have my ortho on. I'll close that up. I can quickly extrude this as a solid, right? I could have just made a primitive if you prefer that. Solid, yes. Direction, I'll move it up in the up direction, positive Z. We'll type in 8. There we are. So now I have an 8 inch by 8 inch by 8 inch cube, basically. All right. Yay. Whoop, whoop. So a couple of things here to think about. One is, these are basically scaleless, right? And so what I'm going to do, just keep in mind I have an 8 inch by 8 inch by 8 inch cube over here. But in the meantime, I'm just going to look at one of these assemblies that I've been working on. Right, I'll just zoom in on it a little more carefully here. There we go. And I'm going to try to identify, let's say, one of these inside out inflected moments, right? I think what's interesting is that, here in this area, right, becomes inside to outside. It's a sort of whole in section, both in section in and plan. And so what I'm going to do is I'm going to make a copy of this, bring it over to my cube. Maybe, here we go. Try to do this a little easier. Just move it over here. Right. When I compare this to my 8 inch by 8 inch by 8 inch cube, right? What I understand is I really just want to crop that moment, right? Just one sort of part of this larger assembly. And so what I'm going to do is I'm going to scale this up. mean, this really isn't any kind of set scale, right? And I'm not so worried about scale at the moment, except to make sure that all of these fit inside an 8 inch by 8 inch cube. I don't know why I'm having a hard time saying the word 8 today, but apparently I am. So I'm just going to move this, start to try to understand what I have here. And try to put my cube over that sort of moment, or that area that I was really interested in sort of sampling here. Oh, sorry. Let me go in side view here and move it up in Z, for instance. I might have scaled this up still a little too much for my taste here. I'm just gonna bring it back down so I fit just a little more inside that box. There we go. Now I just need to adjust the position of the box a little more. Oh yeah, there we go. I'm just going to move it over a bit here. All right. And now last but not least, I'm going to bring it up. Oh, come on, select the box. I'm just going to bring it up. Right, you're each going to identify moments that you want to sort of clip and explore spatially, right? This just happens to be one of the ones that I've identified in my model. Let's say it's this part right here. Okay. I made a copy of the original geometry so that I don't do anything potentially really destructive, right? That's really important. I don't want to, do something and then I lose it forever. So I always sort of make copies that really save, that kind of stuff. So I have sort of different versions of things as I move and do more work, right? And generate more process. So what I'm going to do first, before I start to offset and do things like that, I'm just going to split. I'm going to say split this object. I'm going to use this blue cube as the cutting object. Just want to sort of see what I have here. All right. Excellent. So that's one of my models that I'm going to create as a sort of inside out moment where this surface winds around and becomes wall, then becomes floor, right? It's inside and then suddenly it's outside in another space, okay? What's inside and outside is sort of really, I think, blurred. There's not a whole lot of distinction to be made, right, in this case. Now, I'm going to undo that really quickly, and I'm going to offset my sub D before I then trim it. So I want to give things thickness. I think that's really important. Because once we start to contour this, we want to have closed shapes, right? That would then be theoretically laser cut if we were in person. But we'll do the sort of virtual simulation of a laser cut model inside of Rhino. So I'm just going to go ahead and offset this really quickly. I've been using 0.1. That seems to work okay. Sure, why not? Actually, you know what? I'm going to change the offset thickness here. 0.3 maybe. Delete input, yes. All right. Make it a little thicker. Yeah, why not? Sure. Again, another decision you have to make, right? What's mass poche material versus what's volume empty space, right? Here's another parameter to sort of, I'm actually going to make it thicker than that. I might regret this. Let's see. I'll say 0.75. Oh, yeah. I like that a lot. Okay, cool. All right, now I'm going to go ahead and split it. Split this with this. I always imagine like, a wrecking ball coming through and just destroying half of this. Somehow it's more satisfying that way. All right. Oh, wait. I remember now. The problem with that is that we're trimming everything away. Okay, so yeah, I get it. So what happened is I happen to be using a sub D. I think now these are poly surfaces. Yeah. Okay. So I basically offset that as a solid, but then I started to like slice into it and get it, pull a sample from it. So now I actually have to go through and actually close up these edges again to close them up to make another solid. All right. So there's a couple of different ways to think about this, right? But what I'm going to try to do anyway is just to sort of select this edge and select this edge and then put a surface in between them. So let me try that. Go to my surface tools. You should be pros at this by now. Surface from 2 or 3 or 4 edge curves. There's an edge curve. Those are all edge curves. All right, it didn't work. Well, crud. Didn't that just perfect? Oh, and I know why. It's because these are all surfaces. Oh, interesting. Wow. Interesting how that worked. Okay.
Hey, Josh,
Yeah.
could you split it and then do the offset?
Potentially, yeah. I mean, that's another way of thinking about it. And that way you get a solid. But I do want it to not offset outside of that 8 by 8 by 8. So that's also the issue with offsetting it after trimming. Anyway, this is something that's not too hard to overcome. What I'm going to do is I'm going to make curves from the edges here, and I can join the curve together, and I can do it that way. So there's all of those. Yeah, great. And I'm going to join those together. So now I'll have just 2 curves. There we go. Now I make a surface in between those 2 curves. Yeah, that's much better. I love it when a plan comes together, right? And I can go around and start to close all of this stuff up. That seems to be a decent workflow. I'll try it over here along the bottom. What I'm trying to do is just select along the edges that I want. There we go. All right, so you can see the magenta highlights there. Now those are all curves. I can join them together. So I just have 2 curves. Although it's telling me I have 3 curves. Well, that's interesting. By interesting, I mean frustrating. Oh, maybe I see what's going on here. Cell last. All right. Let me just be a little more careful and I'll do this. I'm gonna go along these edges and make sure I select all the edges I need to, right? So I have a solid sort of edge along it. I wasn't being careful enough to actually zoom in and make sure see, there's a little part of a surface there. All right. And there's more than one way to do this, so I'll do it a different way here in a minute, since this is being recorded for your reference here. Okay, so we have curves. Let's join those 2 curves together. Okay, so we have 2 curves, and now I can do this exact same thing. I can skin in between these 2 edge curves. That works. Yep. For some reason, I have this turned upside down. There we go. So like when I'm trying to turn left, it goes right. That's really annoying. Let me turn it the right way so I can have a little more intuitive control here. All right, there's those. I will make sure those are joined into 2 curves and then surface those. Interesting that we made surfaces. Now we're using surface as a verb instead of a noun. Let's surface that. Oh, oops. I was using the wrong tool. Yeah, I just want to duplicate. When I get all of these edges, then I'm going to turn them into curves. I want to create curves at each of these edges, right? That I can use then as geometry to make a surface later on. So there we go. Join them together. Yep. What was 6 curves are now 2. I can skim those. Just going around trying to be as methodical as possible here. Almost done. Look at that. Traveling upwards. Yep. Yay. All right, so here we go. Another one, another one. Yep. I'm gonna hit Control and see if I can deselect that one. Okay, there we go. All right. That's interesting. I think I'm just gonna deselect that. Yeah, all right. And join and surface that. I'm eventually just going to take away this stupid little leftover surface here. I don't like that at all. I think it's kind of weird. Hopefully I can get rid of that. Well, I don't know, actually. Interesting. Yeah, I'm just going to get rid of it. Explode it. And I'll get rid of this little trim part here. So you can see it's not so clean sometimes when you go from sub D to a poly surface, which is unfortunate, but it happens. Just going to select all the curves that I've made up to now. Make sure I delete those so I don't accidentally try to join any of those. Just select all of these surfaces again, join them together. And I'll just keep going around until I'm done closing this thing up, right? So that's one way of doing it. I do actually like Roger's idea. Of course, which way you'd pick probably depends on the nature of the geometry that you're choosing. I'm just going to undo this.
Well, if you do it inwards, would it stay within that 8x8 parameter?
Maybe, maybe not. It really depends, right? Inwards and outwards is kind of a weird thing. Inwards at the top might be outwards at the bottom, right? Or along the side, right? When it comes to these sorts of geometries. So, what I would say is you can always keep that box, turn it off on a different layer, and then retrim afterwards if you need to.
I was going to ask, could you rescale it if you had to?
Yeah,
just make it slightly smaller. But
so anyway, I'm going to go ahead and use the split again. I'll split this. Something tells me that you'll find this way easier, and most of you will do it this way. So I'm just going to go ahead and hide this box for a moment. Yeah. All right, so here's a poly surface. Now let's see how well we can offset a poly surface. That's the problem. Offset. Oh, wait, what's a curve? Come on. Offset surface.
It's kind of obnoxious, but you could go poly to mesh and then mesh to sub D if you need to.
Oh, no, I don't want to go back to sub D. There we go. I did 1, right? So distance, I'll go back to like 0.5-ish, make it a little less. Delete input, solid yes. We'll go out that direction, sure, why not? There, right? Now if I turn my my cube back on, right? You can see I'm just outside the bounds of it in a few places here, right? So from there I could, essentially split again. Let's see, I'll split this. Delete that part away. Delete these outer parts away. Oops. get rid of that. But essentially, I need to close these up, right? I mean, that's what I want to do here is close these up. So, like once again, I'll just double check and make sure I'm getting these. Okay, perfect. Let's see here. This one and this one. And this one. Nope, nope, nope. There we go. Join those together. Surface those. All right. I can, of course, group those together here in a minute. Or join them, I guess. The key thing is I want to make sure that this thing is watertight, right? I want to make sure it's solid and closed up. Which is the important part. It's also sometimes the not obnoxious part, but okay, join. Oh, oops. Sorry, I was using the wrong tool again. There we go. This one, this one, this one. Make those curves, join them together. Now surface them. There we go. Oh yeah. Ooh, ah. All right. Select any curves. Join this stuff together. Sorry, selected and yeah, join. There we go. 9 surfaces of polysurface joined into one closed polysurface and one open polysurface. Where's the open polysurface? Oh, I wasn't able to close that one up. Interesting. Wonder why. Maybe I should zoom in closer and find that out. Let's see here. All right, I'm just going to brute force this bad boy. Duplicate, duplicate, duplicate. Oh, I see. Interesting. You know what? If I'm having problems with this, I can imagine some of you might as well. So instead of really fussing with this, let's call it a day right here at this step. Like you don't have to like worry about this. Those are not just little hangovers. Okay. So what you can do is do the second part where we just basically split before we offset, right? So we sampled this, then you can offset from there. That'll work just fine. I mean, anything that's carried out over the 8x8x8 envelope, it's probably pretty minimal and small at that point. So let's just do that. Does that make sense? It'll just be a lot easier that way. All right. I don't really want to troubleshoot that in front of everybody for the next 20 minutes and waste time. So, and, you know, especially since I would argue it's kind of trivial, honestly. All right. So we have this thing that we extruded into or offset into a solid, right? Now, if we were going to laser cut a model of this, right? Let's say make it out of crescent board or museum board or chipboard, right? One strategy would be to, you know, slice this into sections and then laminate them back together, right? And we'd get this sort of topo looking model. That's what we're going to do. We're going to do that in section. And so one of the things I'm going to do is I'm going to look at this in top view and plan. And I'm going to make a copy of it before I start to contour it here. Okay. And I'm just going to make a new layer. I'm going to call this contours. Oops. Contours. All right. And so I'm going to use the contouring tool, which you can type in contour, select the object's contour. I'll use that one. Base plane point. I'm going to go ahead and snap or get close to that corner. And I'm going to draw a plane with my ortho on. I'm going to pick the direction I'm going to populate with planes, and then the distance between contours. This is in inches, and we're using 8 inches by 8 inches by 8 inches. So I'm going to use 1/8 of an inch. So I'm going to say 0.125, right? Let's pretend we're using 1/8 inch materials. Now it's going to cut this thing in section, in 1/8" increments, right? Sort of slices, as you can see in the multiple views. All right. I'm going to take those curves. I'm going to very carefully move them over here away from the surface model. All right. Theoretically, each of these should be closed. I'm going to test that hypothesis out by selecting them all at once. And I'm just going to go to my surfacing tools again. I'm going to extrude these. Curves include self-intersecting curves. Sure, why not? Okay. And I'm going to maybe in this top viewport. Okay, sorry. I'm going to make sure I'm doing this in the top viewport. Yes, yes, yes. Okay. Direction. Oh, this is annoying that it wants to extrude in a different direction. Okay, sorry, in this direction. I'm going to say solid, yes. And then for extrusion distance, I'm going to say 0.125 again, right? So I'm going to make 1/8" material slices. I'm not exactly sure what my computer is, why it's lagging so much. Shouldn't be that big of a deal to do this. Come on, computer. Like I said, my Windows is just acting really odd today. I don't know why. I know it's Friday, but can't take the day off here, MacBook Pro. Let me just escape out of this. I don't know why it's doing this, but essentially then I just give it extrusion distance of 0.125, right? And then it'll create the solids. All right, so let me try this one more time. I mean, I don't think that, I mean, it's 8 times 8, so 64 sections. That shouldn't be that big of a deal. I don't know why it's sort of acting like I'm sort of giving me a spit take here when I try to tell it to extrude these. It should be a piece of cake, actually. Extrude. Yes, extrude them. No, I accidentally generated them and then selected them all. Come on, solid, yes. I need to set direction, which is annoying. Here we go. Right, tell it which direction to extrude in. And then I can type in a distance, 0.125, and hit enter. All right. Now, as soon as it starts responding here, it should work just fine. Yeah. Okay. Not sure why it decided to take its time there, but whatever. It is what it is. All right. There. So if we were laser cutting this, we could actually lay out all of these sections one at a time and try to nest them really efficiently in a 18 by 24 or 18 by 32 sheet of material, whatever, right? But for now, this is how, I mean, this is basically a simulation of your model, right? A sort of virtual physical model, if you will, a virtual laser cut topo model in section. So the topo is in section. You know, in Rhino 7, I think by default, if I turn it to rendered, it'll pick a sort of white clay, sort of white plaster material automatically. I'm just going to select those curves and get rid of them because I don't like seeing those blue curves there. Okay. And so from here, I could begin to generate some JPEGs or PNGs. If you don't have, if you're using Rhino 6, here's what I recommend you do instead. Because I'm not really so worried about resolution here. So I mean, I think you can basically take a screen capture, right? View, capture to file when you have the rendering set, right? But for those in Rhino 6, here's what I recommend you do. I think actually by default, The rendering settings will use a custom environment, studio environment. We'll have the skylight turned on, but not the sun. We'll have a ground plane that you want to turn off. Oh, come on, seriously. Go ahead and turn off my ground plane. This is set to, I'll set it to legacy Rhino render. I think that's like Rhino 6 rendering. And as is, I'm just going to quickly hit render and see, hopefully emphasis on render. For whatever reason, I keep running out of virtual memory on this. I'm running Windows through Parallels on the Mac, and it used to not be a big deal, but now it's like Parallels doesn't allow Windows to talk to the Mac video card all that well, so they don't get along suddenly all like in the last month here, which has really gotten in the way of me being productive here. But let me just see what this is rendering as. While that's going, I'll just open up the chat. We went through the same thing. Make sure you save it before it crashes. Yeah, exactly. So yeah, so as you can see, it's still generating, you can set the background to white or to transparent, JPEG or PNG options, right? By default, I think it just uses soft shadows, skylights. I turned off the ground plane, so I don't have a plane accidentally slicing through my model. And then it uses the sort of, sort of a generic white plaster shader without you having to generate anything, which is fine for now for these, right? It almost looks like museum board. Okay, so I'm perfectly fine with that. So this is what it looks like. I'm not going to like sit here for another 10 minutes just to get a kind of, what I would argue is output that is kind of like, yeah, I'm pretty sure I'm going to stop rendering. Okay, so let me just again here. Oh, hey, Windows, why are you doing this to me? Okay, great. Now, the interesting thing about this process, and let me just back up and I'll show you another step to do. Okay. The interesting part about this process is that as you start to contour these, you can start to pick multiple orientations to contour. So the first thing I want you to do is contour in that section plane, right? That sort of elevation, right? As a second study for each of these moments that you pick, I want you to section with horizontal planes, right? So in that case, I'm going to say contour. I'm in side view. I'm going to give it a base point in the side view. Let's see, snap to a endpoint here, right? And give it a vertical line as my axis, right? The distance between contours, oh, I must have my settings just to 2 decimal places of accuracy. I'll just retype 0.125. And it'll start to cut these up in a different orientation. All right, great. So I'm going to move those over to the side as well. Okay. So what I'm saying is that I'd like for you to slice each of these moments that you identify, each of these models that you make, you're going to make 3. One where you're slicing it in elevation, one where you're slicing it in plan, and then one where you're slicing it at some strange oblique angle that you pick. It can be different each time if you'd like, okay? So let me just show you what I mean here. So again, these just need to be extruded into solids by 1/8 of an inch. In this case, what I'm gonna do, since this was being Rhino was being a jackass here, I'm just gonna select a portion of these and do them, do so many at a time here, and maybe it'll behave a little better. Solid is already set to yes, extrusion distance set to 0.125. Hit enter. There. All right, now I'll go do another set of them. Yes, yes, yes. 0.125. Where's my cursor? Oy. 0.125, try this again. Come on. Because they would have made invalid surfaces. Oh, why? Why? Sorry, I apologize. Like, I don't understand what is going on here, but usually I don't have any problems here. I promise you, I'm not making excuses. It seems kind of odd that these are extruding in different.
I think there's already a surface there. Like you can see a blue one, and I think it's trying to extrude that. I don't know if that's the issue there.
Maybe. Okay, so first of all, I guess I have to tell it the direction again is this way. Ugh. 0.125. Okay, yeah, that's working. I don't, for some reason, I was trying to extrude them in the wrong direction. Again, I don't know why it's doing that, but it's fine. I mean, I can always specify here a direction, give it the Z in this case, 0.125. Let it do its little math. All right. Okay, so there we have the same model, but sliced in the opposite direction, right? Sliced horizontally rather than an elevation. Okay. And again, for that third sort of slicing, right? I want you to do it on the oblique. So what that means is I want you to pick an angle that isn't orthogonally oriented. Let's say I draw my own axis here, like this way or something. Okay. So now I'm going to contour this. Contour a base point. I'm going to snap here and then snap here. This is between contours again, 1.125, right? Now it's going to slice it at a completely oblique angle, right? Which I think will be also another interesting way to sort of see these things. And again, it's not really costing you any like money or materials here. And so that's why we're sort of teasing out lots of different situations to sort of explore. Okay. Instead of extruding as a solid, there are other ways you could begin to think about how to give these things thickness. If I select all these things at once, theoretically, they should be closed and planar. And so I could actually say make planar surfaces from them, right? Then I could take those surfaces and basically offset those with as solids, right? So I could say offset. Let's see, cap. Oh, wait, none. Where is it? Loose, solid, trim, both sides. Distance would be 0.125. And then
the offset surface now.
Oh yeah, sorry. That's why I was like trying to figure out why it doesn't give me a solid option. Okay, sorry. Offset. Yeah, that's annoying. Offset surface, that would help. I'll just select the last things that were generated, in this case, the planar surfaces. Distance, 0.125. Solid is set to yes. Yeah, sure, why not? Okay. That seems to be giving me less hiccups because I don't have to like sit there and let my cursor drag around. It's just sort of going right now, 64 times or however many slices there are. Yeah, okay. So that's actually contoured on some sort of alternate oblique angle, right? Not an orthogonal direction. All right. Select all curves and delete those away. All right. So that was a lot of minutia and a little bit of troubleshooting involved, and heck, it seemed like even I couldn't figure out what was going on at certain points. Okay. Is the workflow like how to get from where we started to here relatively clear? Like just technically what we did in Rhino. Okay, because if not, I can redo it again in a little bit. Okay. So now let's talk about what I expect you to do over the weekend. Okay. Using any combination of some of those surfaces that you generated and any of the things that you started doing with those surfaces, those inside out assemblies that you've been looking at, right? You're going to zero in on 3 specific inside out moments. Arrange them, arrange each one inside of an 8x8 cube to crop just so we can see that moment, that sort of, that the phenomenon, that inflection, that twist or that self-intersection or whatever, right? Where inside becomes outside, or it's not clear what's inside or outside, or where wall becomes roof and then wall again on the other side or something, right? So 3 moments that you find particularly interesting formally and spatially in this sort of idea related to inside out, right? So 3 inside out moments. For each of those, right, you're gonna slice in elevation once, you're gonna slice in plan once, you're gonna slice in the oblique once, okay? So in other words, for each model, you're gonna have 3, each moment, you're gonna have 3 models like this, right? One that's cut with horizontal planes, one that's cut with vertical planes, and one that's cut with oblique planes. 3 moments. Okay. Now, let's talk about scale. In addition to 3 moments to identify, I want you to also identify 3 inside out sequences, spatial sequences. Right. So a larger sequence isn't just one moment where we start to look at the surface. The spatial sequence begins to talk about a volume and how it changes as you progress through it, right? So one way to think about this is something that where you're capturing multiple spaces and volumes on the inside, right? Or a progression where a long small space suddenly transforms into a tall big space or something like that, right? But what you're going to do is you're basically going to zoom out a little bit and include more in these sort of inside out spatial sequences. Now here's the weird thing, right? I want those to also be formatted in 8x8x8 cube. So in that case, you're going to shrink or scale down your inside out assemblies as you start to identify these 3 other inside out spatial sequences, okay, in order to contain an entire sequence within an 8x8. Okay, so what I mean by a spatial sequence, let me just give you an example of that really quickly. Yeah, maybe we'll try this one. Sure, why not? Let's see here. Is if I start to look at this more closely. Sorry, it's lagging on me because it's in rendered mode. Let me turn it in shaded mode and it'll be a little smoother. Okay. If I start to look at the inside of this thing and how I can inhabit it, first of all, I'm just going to turn my viewport camera a little wider angle so I can see a little better inside. There we go. Right. Here I can begin to see a large space that proceeds into a smaller sort of space that sort of cadence of small and large spaces that flow both laterally and vertically, right? And so what I'm going to do is I'll go ahead and make my 8x8 cube. First corner of base, 0, 0, 0. Other corner of base or length, 8, 8, 0. And then height, 8. It's going to be off over here somewhere. There it is. Again, I'm probably going to scale this up, but not as much as before, right? So I'm just going to eyeball this a little bit. Yeah, and I'm going to look at the multiple viewports so I can actually see if I'm sampling what I'm sampling here. There we go. Oh, yeah. Okay. And so scale this back down just a smidge. Come on now. There we go. Just like that. All right. And let's see. An elevation, I'm just going to move this box down a bit. There. Oh, yeah. That's just great. Incredible. All right. So I'm going to go ahead and split this with this. Maybe. What happened? Oh, no. What is the deal?
I thought split only worked if the extents of the cutting object go past the model itself.
No, as long as they intersect, it should work. Split, split. Maybe I accidentally hit trim. Well, that's weird. It left me that thing on the outside. Oh. I wonder why I just split that part off. And left everything else intact. That's weird. All right, so instead of that, maybe I'll use trim. Select cutting object. All right. And I'll trim that part away. I trimmed everything out. Look, what in the world? All right, something maybe is flawed with my logic here. Oh man, oh man, oh man. What a day already. I mean, I'm not crazy, right? I should be able to split that bad boy. Look, I don't get it. What in the world? The reason I say that is because this should be, I was thinking maybe if I, no, I won't even go there. This is why I just should not have gotten out of bed today. I just knew today was going to suck. I always blame it on karma somehow. Select objects to split. Yeah, okay. All right. So I can move that away, but what's going on now? Select objects to split. Come on, split. Huh. All right, well, maybe I'll just move this over. And
What happens if you Boolean it? I don't know if that worked, but
yeah, I thought about that. Then I'd have to offset the the sub D ahead of time? You know what I mean? You try to sample a different portion of this and see if that makes any bit of a difference. I'm not sure why it would, but split this. Huh, yeah, it worked. I don't know, for whatever reason, I just happened to line up with an edge somewhere that it was, I guess, not apparent that, what would happen, right? So in this case, I'm there's more than one moment here that I would say, like we were talking about before, but like a sequence of moments, right? Both spatially and inflection wise, right? With the surface, okay? So these are going to capture a little more, right? These three sort of inside out sequences, right? And again, just like with the moments, you're going to do three of these, and then you're going to cut them three different ways, right? Horizontally, and then an elevation, like in section, and then at the oblique, okay? So you'll have three sort of 3 times 3 of these. Does that make sense? You identify three inside out sequences, and then each of those sequences that you clip, then you'll make 3 different contoured models.
Are all of those derived from the same parent shape, or can we use multiple?
You can mix and match from your studies, from your surface studies already.
Okay, cool.
But it's up to you to pick. What do you think is the most interesting and fruitful?
Are we supposed to take our shapes and copy and paste them like you did?
So if you think that's appropriate and you want to try that, go for it, right? Some of you have some shapes that are interesting regardless, particularly if you're just looking at the moment. When it comes to the sequences, right, you could always, in fact, one way to generate a sequence is to look at moments and then, start to put those together in interesting ways, right? Whether it's mirroring or something like that in order to generate your own sequence. So that's another way to think about it. So I'm not really constraining you either way, I guess is my only point, Tyler. Right? You could generate the sequence with more studies, copying or mirroring or that kind of stuff, right? Or you could, it might have been generated, an interesting sequence already, just from what you did in Grasshopper originally, right? You can be the best judge of that, I would think. Okay. So we'll have 9 contour models of moments and 9 contour models of sequences, right? You pick 3 moments, do 3 models of each moment. Pick 3 sequences, do 3 models of each sequence. And like I said, once you get the workflow down, hopefully it's not too bad, right? It looks like the goofiest part's going to be offsetting some of these poly surfaces in some cases, right? So keep in mind when you have something that turns a corner really sharply, the offset becomes really pronounced, and that's where you might need to thicken or thin your offset, depending on making sure that you don't have too much stuff that's self-intersecting again. Then again, self-intersections and that sort of stuff might actually be interesting as well. So what I'm talking about is, let me just show you here. I'll offset this, offset surface. And for a distance, I'll put in something probably too large, such as, let's say, offset distance of 4. Something just ridiculous. And I wait. All right. I can see this is kind of a complex thing. So this is why it'd be so much more ideal. It seems like it has fewer problems when this is just one sub D. You can offset it nicely instead of a bunch of surface patches that are joined together in maybe less ideal ways, but one way or the other here. It also doesn't help that my computer is like melting down, I think, half the time. So Weird, because if I offset this as a sub D, you wouldn't have had any problems. But so when you run into this situation, see if I can escape out of it. You know, in this case, I might just undo the split, go back a little bit and do the sub D. If you're using the sub D, go ahead and offset before you split. Distance 0.75. Sure, I'll try that. Why not? Yeah. And then I'll go ahead and split. Let's see, split. I'll split this with this. And if all goes according to plan, it'll actually work. Right. But then I'm faced with closing up these open edges, right? What's really important is to close up. The reason you want to close up these open edges when you start to contour these things, it's a lot easier if everything's closed here at this step. So then you have a bunch of closed shapes you can easily surface and then extrude or offset to create this sort of pancake layering, right? So yeah. The other interesting thing to recognize is that you could, when you still have the cube here and you've split and you've deleted everything on the outside away, is you could do a second split and you select everything but the cube. Or sorry, wait. You select the cube to split. Then you select everything but the cube as the cutting object, right? Then you can delete portions of the cube away, and the portions of the cube that remain are those edges that you need to close things up, right? So that's another way of doing it. That might be kind of helpful. Oh, isn't that gorgeous? Oh yeah, I think so. Yeah, look, that was like one operation and it solved the problem, right? So use the box to split the surface and then use the surface to split the blocks, and then it's what you keep and what you delete. And suddenly you can have a closed shape. Let's test that out. Let's select everything and hit join and see if it joins into a closed poly surface. One closed poly surface. Oh, that is just gangsta. Finally, the stars aligned. The universe is in harmony. All right. So from here, then I could, again, start the contouring process, right? Contour vertically, contour horizontally, contour at the oblique. Okay. What I recommend doing for the sake of memory is to, and also to sort of keep things, you know, try some naming conventions and start saving as different files in case you do have a crash. You know, you just lost like, you know, 5 minutes of work and not like 5 hours of work, right? So if for some reason you can't recover a file after a crash or something like that. But that seemed to work pretty well, right? Split and then split again. That's actually can really appreciate this. I might try to do something with this later just on my own because it's just nice. There's something great about like sort of thinking about this as its own separate unit. I have a feeling my 495, 795 class is going to be using this kind of technique to make their own custom masonry blocks. Oh, it's going to be awesome. Anyway. Okay, I'm going to save that so I can remember that. Gyroid study, why not? Okay, so that's to sort of sum up the stuff. I think Gabby was in the process of sort of putting together a PDF, sort of talking about this process. She was running into issues. I ran into issues today. So I recorded this session. And so once we're done with Studio, I'll go ahead and start uploading that to YouTube, and then I'll embed it into Canvas for you, okay? And make a new page and label it so you can see it in the module, okay? I'm going to stop sharing for a moment, and I'm going to turn off the recording.